Okay, I think we should be good now. Good morning, everyone. Hope you've had a great weekend. Whatever you do on the weekend, I don't really know what anyone does here with lockdown and everything. Um, we have a few little fun topics to go through today. Most of this week is actually just to talk about testing. So it's a very big testing week, which is kind of fun, kind of interesting and exciting. I think the only interesting update to share with you, it's not really an update, it's more just a reminder, is that don't forget that when it comes to both your labs and your major project, that sometimes we as course staff will push out updates to your repository. So for instance, if we take a group like F17A Eagle, one thing to just keep an eye on is this little merge request tab in the sidebar. At the moment, you can see it's got a 0 next to it. Though what we do often, well, not often, this term we've been pretty good and haven't had to do this much, but like what we do sometimes is we essentially make commits on like on the template repository, and we push them out to all of your repositories. So sometimes there will be a clarification or something else, and you can actually see this with the spec itself, that there's actually been two clarifications here. So on both of these dates, we actually pushed out a little bit of an update to your repo. Most of the time it actually gets merged in automatically. So what actually happens is that if git can, it will simply take our commit, and it will just like push it straight onto your commit. So all you actually would need to do normally is just pull master normally, as if someone else, like a sixth team member, has merged something to master, right? That's kind of the behavior. Though sometimes if there are merge conflicts, which there rarely are, you might have to resolve it manually. Generally, because the only thing we tend to update is the README, it's usually okay, though that's just something to keep in mind, and I think that's something that we just hadn't really reminded you much of throughout the course. Only other interesting things today, where I'm living is getting NBN on Friday, so the stream quality will improve next week. That I'm looking forward to. Thank you for putting up with a slightly substandard stream quality for the first few weeks. I appreciate it. Doing my best. And the other thing which Basim Bassem has mentioned is when is the project leaderboard coming out? It's going to come out around lunchtime. We're going to talk about it after the break, probably at the beginning of lecture 3.3, I think. So we'll kind of come back to that. Just to answer some questions about the merge conflicts, though. Hussein says, does it only prevent a merge if there's a conflict, or also when it causes master to fail pipeline? Look, it will only prevent a merge if there's a conflict. Generally speaking, we don't push updates that might cause master to fail. I'll give you a really good example. So just double check if these guys have updated. Yeah, I don't think they've updated this, but so we have a user file somewhere. So I'm just very hesitant to open anything up because I don't want to show anything. Anyway, you've probably seen on the forum, and I've actually made a pinned post, so you'll actually be able to see this. Let me just log in. So I'll give you an example of sometimes we don't fix things up. So if we go to 1531 and then we go to this one, channel details. So on channel details, we actually forgot to include an element that private is public property on the stub code. So the spec's right. The spec's always right. If you do what the spec says, you'll be fine. But we forgot to include it in the stub code. We would not push this fix out because it's so likely to break so many people's code. Because if you've actually implemented this, you're going to get merge conflicts. It's just not going to make sense. So in this case, we just put a clarification in the spec. So we tend not to do things that we think will break students' code, and that's just selfish. Like otherwise, we'll get hundreds of forum posts about it. But this has been a pinned post now. Generally speaking, as well on the forum. What I look at all the forum posts. Nick and Emily are great helping out, but I look through them all generally. What we do is we pin posts anytime we think everyone should probably read it. If it's something that we think everyone has to read, like it's like a requirement, we tend to put it in a notice, make a clarification, talk about it in lectures. So there's nothing on the forum that we expect you to see, though it's kind of like this one was clarified in the spec, but we thought this one's super useful, so we'll pin it so that anyone on the forum will have a glance at it. That's kind of how we operate. But babble. Let's get into today's lecture. So the 3 lectures we're going to be looking at today are Python objects, testing, linting, and continuous integration. Then tomorrow we have a couple more on testing and a fun side topic that isn't related to anything. So a little bit of Python today, then a lot of testing. So let's start with Python objects. Now Python objects is it's like a lecture topic piece that it really focuses on the fact that Python behaves a little bit differently to C in the sense that it kind of has these objects, like you have a list which you can call .append on it and stuff, so which is a little bit different, and we kind of just gloss over that and say, well, just figure it out. It's like kind of intuitive, and it is very intuitive, and students often pick up on it like that. So rather than wasting all this time in week 1 going through the theory of how the Python language works, we instead just kind of talk about it in week 3 and be like, all right, well, you've used this now. Let's just really quickly talk about what this actually is. And I mean, we've started with a great question here, which is, Amir said, will we be graded on whether we use objects in the project? So I'll chat about this towards the end of the lecture, but there's a very big difference between using objects and creating your own object types. We're not going to be talking about creating your own object types. We're going to be talking about using objects, because in Python everything's an object, right? It's just how it works. So but if you bear with me, we'll kind of cover that as we go on. So firstly, again, in this lecture, I mentioned Python might be one of the first languages you've used that has a widespread notion of objects. In pretty much every other language I've come across that isn't C or as high level than C, those languages have objects. Sometimes the question is how widespread are the object usages, but generally pretty much everything has objects. Java's nearly totally objects. I believe languages like C++, Python are totally objects. Same with JavaScript, C#, I'm not too sure, but like tons and tons of stuff. So this is a super generalized principle that you can take anywhere. We're going to talk about the object model, and we're going to run through a pretty simple example of it. So what in the world are objects? You're used to, when you think about objects, you can kind of think about them as data types, right? They're instantiations of data types. So you know that in C you have an int. An int is just a type. It defines what a certain thing is, and whenever you create an int in C, like int A, int B, int C, you can kind of imagine that as you're creating little objects. They're little chunks of memory that have stuff in them. And typically in C, you have, if you create an int, you could think of it like you're creating a 4-byte object. It's an object with just enough space to store an integer. It doesn't do anything interesting. It's just enough space. In a language like C, you can also create a struct, which is a group of, a couple of data types. And yeah, this #C is a Python comment. I don't know why I did this. It should probably be like a //. This is very confusing because it looks like C# written the wrong way around. But yeah, so a struct is like a collection of underlying little pieces of data that form an overall object. And you know that a struct itself is actually just a data type, and you can go and create many of these structs. So you can go and create struct point 1, struct point 2, struct point 3, not C. And they're all just like kind of different instantiations of this same data type. Like these are notions you already kind of, you already understand. Sorry, there was okay, cool. So simple types in C were basic types that occupied limited memory, right? Int, double, float. Even structs were just collections of those. Those structs you can kind of imagine were a collection of primitive objects, and we could just for concept's sake say that's an object. So a struct is like an object. That's how we think you should probably start trying to understand this topic. So with structs again, you would create instances of the struct as objects, and then you'd access properties within them. So struct's a data type. You create instances of that data type, so you could make many of these 8-byte objects, which are structs. And then you can access elements within those, and if you take that understanding, we can just expand that into the world of Python. In particular, in Python, you might have something like this: list equals 1, 2, 3. Okay, well, what in the world is list? Well, it's not a struct, it's not a primitive data type like an int or a double, but it's actually this notion of an object. It has many bytes. Who knows? You might think, oh, it has 3 bytes because it's got 3 numbers. You don't know that. It's probably much bigger than that. And one of the most, you know, one of the most simple ways you can kind of understand what a Python object is that it's simply like a C-style struct, except it has functions attached to it. It has functions that are part of the object, right? So in Python, everything is an object: an integer, a list, a dictionary, a tuple, a string. These are all objects, which means they're all this kind of collection, this dump of data that has a bunch of properties in it, and just happens to have functions attached as well. So in Python, the only other kind of note to make is that, because I think most people kind of get, okay, well, an object in Python has properties or attributes, right? Okay, so it's like a struct. Got it. That's pretty manageable. It also has functions. That's a little bit weird, but I kind of get that, because you might do something like list.append or list.size or you know, something like that, or you know, a dictionary.keys or a dictionary.values. These are all functions you're calling on an object. Maybe that's a little bit conceptually weird, but you've probably used it by now and you're like, all right, it's an object, it has properties, it has functions. The only other interesting thing is that you can construct an object. That's something that you probably haven't seen much to date, because most of what you've been dealing with are probably lists, dictionaries, tuples, and strings. And those four objects they're so commonly used that you kind of get around that one. But we're going to talk a little bit more about constructing an object, because that is one kind of biggest difference with, you know, a language like C. But again, Python objects, it's like structs, except there are functions attached and a whole bunch of other random things that aren't as critical right now. What I have here is a simple example of the usage of an object. So let's actually play around with this code a bit, because I think datetime's a library that most Python, you know, developers end up using at some point or another, and we can play around with it. So I'm just going to put this one in. I'll just create obj.py. I'm just going to put it here. Sometimes it doesn't like me doing this. Sorry, this particular one I didn't put in the. Give me a second. I'm on like a customer service call line, and I keep getting these random calls. Oh, interesting. Someone's talking. Okay, so let me just copy this code. Might have to do something more brash with it. I don't understand what's wrong with it. Sorry, everyone. Hey, brilliant. Okay, so we've got our code there. Let's make this bigger and play around with it. Okay, so great. Object.py. So have a quick look at this one. What you'll kind of see with this is that a lot of this semantic kind of looks pretty clear to you. You know, you've got this like object and you're doing stuff with it. But let's actually step through it. So datetime is a library. Okay, datetime's like a module. Think of it like a file. Think of it like a datetime.py. There's a datetime.py file somewhere on your computer as part of the Python library. I mean, maybe not. I'm not sure if it's a built-in or not, but it's there. It's some kind of library. When you say from datetime import date, what you're actually saying there is I would like to import from the datetime library an object called date. And this is really no different to if you created a file called you know, hello equals Hayden, and you save that file in blah.py, and what your import there would be from blah import hello. So blah is your file here, and if you were doing this from another file, and then hello is your object, right? Because let's start referring to Python variables as objects, because everything in Python is an object. String's an object, blah blah blah. It's all an object. So what's happening here is we're from the datetime library. We import date. Great. Okay. Now, one unique part of objects that we're just going to talk about briefly is this idea of construction. So typically most Python objects, you are able to create an instance of it by saying that a variable name is equal to, and then you use the object type or name or whatever, and then you and then you give it some properties, right? Now, what properties do you give it? Well, that depends on what the specific object is. In this case, date, the properties that it takes in to construct it is actually year, month, and day. So when you create a date object, right, from this date type, you go year, month, and day. Now, again, I am simplifying a couple of things because this course is not about 6 weeks on objects. So if you know more than this, then don't be surprised that you're like, oh, there's some extra detail here. What's important though is that when you create an object, whether you create it or not, in fact, we don't even need these properties. We could just do this. We could just do something like this, for instance. You can actually access particular properties of that object via the dot. So if you have your object today and you say, today.year, today.month, today.day, you'll actually get stuff, get values. And then similarly, we have functions like .weekday and .ctime, and these are all particular functions. So let's actually run this code now. Python 3 object.py. Oh, it actually does want it. Okay, that's fine. And sometimes when you construct objects of certain types like date, the rules around like what you have to pass in are just, they vary. Some objects you don't pass anything in. Some objects you have to pass something in. In the case of date, it wants something passed in. And have a look at what's happened here. So we've printed out today.year, great, 2019, today.month is 9, today.day is 26, and then we printed out today.weekday. So we call a function which returns a value, and that weekday is 3 because Monday, I don't actually know what weekday does. Let's look it up in the Python library. Python date weekday. So let's go look up the function in Python that can operate on a weekday object, on a date object. Sorry. Monday is 0 and Sunday is 6. Okay, why the hell did it return 3 then? That's weird. Not too sure. And then we've got ctime. And ctime is, again, we can look that up, right? Like, a lot of people wouldn't store these off the top of their head. The stream speed, the stream bit rate's kind of fluctuating right now. So if we're lagging for people watching live for a bit, I'm sorry. Again, we'll sort this out by next week. The method ctime converts a time expressed in seconds since the epoch, I'm not sure how to pronounce that, I never have, to a string representing local time. Great, so it's literally just a local time string. So that's why we get Thursday, September 26th. Oh, sorry, yeah, of course it's a Thursday because we entered a Thursday. I got mixed up and was like, oh, why is today's Wednesday though? But it doesn't matter because the date we gave it was the 26th of September 2019, which I'm pretty sure is when this code example was probably written. Great. That's how you use an object. So just to like really play it back out with really specific language, datetime's a library. Date is an object type. It's a type. We create a new object called today, and we create that by constructing a new date type. And then today now has properties like .year, .month, .day, and it has functions, .weekday, .ctime. You can also call these properties attributes, and you can also call these functions methods. And then lastly, let's just print out the type of the object. Let's see what this gives us. Cool, Python 3 object. Okay, so you can see here that it has class datetime.date. So when we print out the type of our object, we get told it is a date class. Okay, what is a class? That's not really super important for this course, but the simplest answer is that a class is a type that describes a particular object. It's an object type. You know, so like an int is an integer type, a double is a floating point type, a class is an object type. And in Python, because most things are objects, most things are also classes. Now, just before we kind of move on from that and talk a little bit more about Python and objects, I'm just going to read through some of the questions that have been asked in the chat. So firstly, Art Smart said, are there pointers in Python? I think we might have touched on this right at the start, but Python itself does not interact with pointers. Python itself would use pointers somewhere, but you as a programmer do not interact with those pointers, right? So that just means that while every language is going to have to interact with memory somewhere and use pointers somewhere under some level of abstraction, your interface with Python does not involve pointers at all. Yeah. Okay. Amir's question. What was it? It was honestly, when starting out with OOP, it helped to visualize objects as instances of structs. Yeah, great. Just reading more. Sorry. I'm not too sure what tutors have advised against. People are saying my tutors advised against it. I'm wondering what that's in relation to. Okay. So I think Amir said a question which is like, why not create your own objects? Why not create your own object types, which are called classes? Why not create these as part of your project? I think a couple of things to this. I get why your tutors say you shouldn't do it, because I don't think you should. I don't know if we would strictly say that you're not allowed to. And what people keep saying, like, there's just this phrase, people are like, can we use objects in the project? You're using objects all the time. If you're storing a list or a dictionary, you're using objects in the project. The question is, can you define your own object types and use those, right? That's kind of the question. And I answered this on the forum to someone, but essentially, the problem with creating your own object types is that we're not teaching it. And if we're not teaching it, it means that you're going to have to teach yourself. And it's not just enough for one group member to teach yourselves. You have to have an entire group passionate about teaching yourselves how to manage object types and agree on that fact, because you're not going to get help if things go wrong. You're not going to get special whatever. So it's kind of like there might be one or two groups out there in the whole course where every group member's like, we want to teach ourselves user-defined object types, and then goes and does it, and it's not going to make the project much easier. I mean this sincerely. Like, it could be an interesting exercise for people, but generally speaking, it's not going to make the project a ton easier. So, it's all pretty fine. Don't know why the internet's so choppy. Okay, moving on. Some last kind of reminders here, last couple of slides. So again, everything in Python is an object, and I just want to reiterate this. So this isn't some kind of new concept. This is just explaining something you've been working with already. So when you create a list, dog, cat, chicken, and you append to that list, you are appending to an object. When you create a string and you call the .capitalize method on that string to get the capitalized version of that string, you are using an object, right? Animals is an object, greeting is an object. Sometimes you're, getting properties, sometimes you're getting functions. More often than not, you're going to be using object functions, or what we call methods sometimes, to interact with your object. Getting object properties is a little less common. The reasons for that you can discover as you go do 2511 or another object-related course. Now, I've started answering this question around, can I define my own objects? But I feel like I've answered it. But the more important place to start is to say that, this is a new slide, so sorry for the typo. Is Python an object-oriented language? Now, if you haven't worked with an object-oriented language or whatever, many students will have heard of OO, right? You would, object-oriented language, OOL, OO, whatever. And this is kind of question, is Python object-oriented? You hear about objects, so like, is it? The answer is sort of. You have languages like C, which are what you would call purely procedural languages. They're just like start, stop, they just run, there's data types. Very straightforward. Then you have languages like Java, which are what you call object-oriented languages. You can't write any Java, like the act of writing Java, which you'll come to do in another course, is by definition writing your own objects. Like Java is just a series of writing your own object types over and over again. You can't kind of do anything else. It's just how the language is rigidly designed. Python is a bit different. Python is like a procedural. That's two typos now. I'm sorry. Python is I wrote this one last night because I was like, I really want to add this today. I was thinking about this lying in bed, but like, Python is a procedural language with OO capabilities. So you can actually do object-oriented stuff in it and make it feel like an object-oriented language, but it's not required. So that's why a lot of the Python you've written so far and the Python for the project doesn't need user-defined object types because it's not a strict object-oriented language. And Riley on the chat said, so for the assignment, data store would be an object and the class would be the underlying functions that define it, such as .get. So I'll just reiterate this again. It's like everything in Python's an object. It means it's a little struct with data inside of it and functions. A class is an object type, right? So when you create a few dictionaries, dictionary 1, dictionary 2, dictionary 3, you have 3 objects. But there's only one data type. It's just a dictionary type. It's a type. It's like an int or a double. A class is a type. It's an object type. So when we say, well, what's the type of this today string? Today is an object. It has memory. It's got properties and functions. Type will extract what the name of the type is that object is of. So that object is called today. It's the today object, and it's of type date. So sometimes we might say it has a class type date, etc. Okay, could you all leave some feedback on this? That would be great. Thank you very much. Cool. Sounds good. Pause the video if you're watching live or recording and just share some feedback. That would be excellent. Thank you so much.